Well, now we will take a look into two new concepts. The first one is TCP, and the other is reorientation movements. For that, we have a training station here at ABB's Robot Studio, but the concepts are the same for all robot manufacturers, basically, including KUKA itself. So I have this tool here in this case, which is an SMC gripper, and you see here that I have Cartesian coordinates here, one in the tool direction. And the simulator is very easy to visualize it. So those are coordinate axes that maps the space around the robot's tool. And the center, the origin, which is right in the intersection here between those three coordinate systems or coordinate axes. In the origin here, I have my two center point or TCP. And this is the center, this point defines the initial position of this coordinate system. So it would be 0, 0, 0. And that's the TCP. I can refer points in space using this coordinate system and my tool center in the axis. Back here, I have a different coordinate system between the robot and the tool. So this is the end of the robot, and here is the tool. It is very useful when you need to work in a robot that don't have a tool. You can use this point here, which is called 2, 0, and you don't have a tool, so this will be the end of a robot and the best point for you to use as a reference. And it is very nice to have these coordinate systems because you have points here to refer when moving the robot and use them as a reference. Um, so basically what we're going to do now um, is to see what a reorientation movement it is. And actually, this movement is moving the robot without moving the TCP. So basically in ABB Hero Robots here, I can select the tool point that we shall use as a reference. Here I have 2, 0 and the SMC Gripper 2 TCP. I will select my tool here because I want to have the TCP as a reference. And now if I conduct a reorientation movement, um, let me just get in front of the robot. Okay, and note what happens um, when I perform a reorientation movement using my TCP, which is this point as a reference. Focus on this point where TCP is. I will move reorienting the robot in this direction here. Note that TCP does not move. The rest of the robot moves, but TCP stands still in one fixed point. If I move to the other side here, you can still see that the TCP does not move at all. The robot moves, but not that point. Note that the robot uses all of its joints to guarantee the stability of that point that I want. Okay, so let's move the robot back here. Let's rise the robot again. And always remember, as I showed you, do always select the correct tool. Be sure that the movement is referring to the correct tool to avoid having problems. Let's just adjust a little bit the robot here. Good. Let's see here. One example on what happens if we select the wrong reference. Let's move to 2, 0 here. Let's imagine that my robot was already assigned to 2, 0 because it is a new robot or something like that. But now I installed the SMC gripper here and I need to move the robot now. But I didn't realize that 2, 0 was selected. So here I have 2, 0 selected right there, but I actually wanted to move related to CCP. What happens if I move the robot as it is right now? Focus on the TCP here. Let's see what happens. Now it actually moves, so TCP is not static because the reference point is 2, 0 and the 2, 0 point stands still, it doesn't move. But TCP, which is the relevant point for the process, moves. So basically this movement doesn't make any sense for us to do a reorientation movement considering 2, 0 when I do have a 2. So make sure that you are working with the correct reference for the correct 2 that you're using for that specific process. Okay. Let's now perform a linear movement for us to be able to visualize some of those concepts in practice and see how we can handle the robot in different situations. For linear movements, I will switch. Now I'll move the robots in the Y direction here. You can see that the robot follows the Cartesian plan, and I'm moving in one fixed Y direction. Now let's move in X direction. Now on Z direction. So, uh, okay, so imagine the following. First, imagine that I need to bring the robot to get this piece here. If I needed to command all the joints manually, I would go to joint mode and move joint 1, let the whole thing to the other side there, and I will need to adjust other joints to get the robot exactly what I needed it to be, to get the tool. And this it's not easy. Look, see that the robot is not, it's tilted. So I could think of maybe moving joint number 5, okay, but I need actually the robot down a little bit, then I will need to select a different joint, and this is very difficult. If I have to select a reorientation movement here, we will see that it's much easier to align the robot and to move the robot around. So I'm selecting TCP here, everything's correct. Imagine that I need to pick up that piece here. I can get down on axis Z on a linear movement for the two to get closer to the piece. Now we need to align the robot to make it perpendicular to the piece, straight up. And we can use this, and we can make this using reorientation. See how easy it is? Much better. Okay, so let's move the robot so we can pick up the piece correctly. So let me just position it better here. Okay. Now let's move the robot. I need to come here, select linear, and move in this direction here, bring him to the piece. Now move on Z direction. Okay. Now my robot is tilted, is not perpendicular to the piece. See the situation here? Okay. So I need to stay perpendicular to the surface, as straighter as possible, just like I would do if, for example, I need to drill a hole in this piece using a drill. So I will adjust this using a reorientation movement with a reference to TCP. And if I don't, it will take a lot of time if I needed to do this joint by joint. So let's straight it up. Okay, now I select here linear so it can get closer to the piece, move down a little bit. In real life, it's easier to see if the robot is in the correct position. So here in the simulator, we need to move the camera actually to see it. There's still some space here, so we need to adjust a little bit more here. Let me zoom in. Yeah, clearly not perpendicular. I don't have a square to check here, but